Almost.
Negative 1. X over Y.
X over Y.
Negative.
Negative. Negative X over Y.
I thought you couldn't take out the 2's because they're different variables.
No, they're just constants now. It's 2 times, 2 times. Okay, take a look now at this. Take a look now at this. For the first time ever, our derivative looks different than before. Before, the derivative was always something like this. All you had to do was plug in an x value and you can get the number, the derivative. Here you need an x and a y. So the derivative isn't just dependent on the x, it's also dependent on the y. Just like this. The derivative isn't just dependent on the x. You plug in x equals 1, now you need a y. Y equals 1 or y equals negative 1. Do you see that? So we're like expanding our base every single time. Okay, Leah.
So you only do this when it's a circle?
Find dy dx if y squared is equal to x. Okay, so take a look. We're gonna take a derivative here. So we have y squared is equal to x. We're gonna take a derivative. So d dx. Okay, on the left-hand side, the variable's y, but the derivative is d dx. So you're gonna do 2y dy dx is equal to the derivative of x is just 1. Now, yep.
I thought that we could only like continue with a problem if it was x squared plus y squared.
No, that's one example that you can apply implicit differentiation. There are thousands of problems that you can do it with, and you'll know when. You'll either be told or you'll know. Okay, this process is implicit differentiation. Okay, so now I'm going to divide by 2y. So dy dx is 1 over 2y. Okay. So that's dy dx. And then it says find the slope at the point blah, blah, blah. Now, you have 2 points for which to find the slope. You don't have to know how to draw this relation, but I'm going to show you how to do it anyway. But no, just so I'm going to draw it here for you so we know what we're looking at. Okay, you know y equals x squared is a parabola, but here the square is on the wrong variable. The variable that's squared okay, so it changes how the parabola looks. So this looks like this. It's a sideways parabola. Okay, guys.
No, he guessed.
Oh, I see. Okay. So take a look. So now we want the slope at 4, 2 here, and also 4, -2. We can go over why it looks like that, but it's not important right now. So now, here we go, guys. That notation that I introduced you guys to way back when is going to come back now. So here we go. We're now going to evaluate dy dx. So look, dy dx, look at the words, evaluated at, vertical bar, 4, 2. Okay? So for all the x's you plug in 4, for all the y's you plug in 2, this one is 1 over 2 times 2, 1 over 4. Because there's no x, it's just y. Yep.
Why don't you 4, 2 not 4, negative?
I'm going to do that next. That's just because it's listed first. And then 4, -2 is 1 over 2 times -2, -1 over 4. And that makes perfect sense because look, here there is positive slope of a fourth. Here there is negative slope of a fourth. Right? So do you see how it all makes sense? Yeah. Okay. Here's another circle. And it says to find the slope at that point. Slope means find a derivative. Okay, so let's do this. Okay. So it's going to be ddx, right? Because the first variable is x, the derivative is just going to be what? 2x. Plus, how about the next one? Okay, so first take a derivative, 2y,
2y,
2y, then dy dx. You're gonna learn, and equals what? Derivative 0. Okay, so you're gonna learn, you're not gonna get confused by it all that much, because you're gonna learn every time you're dealing with a y, just take a derivative and then just attach a dy dx. Yeah.
Can you divide by dy dx instead of having to divide by 2x and 2y?
No, because if you do that, then you have to divide here, then you get it in the fraction. That's never a good thing. Okay, but what we can do, divide by 2, divide by 2. Okay?
Why wouldn't you just subtract the 2?
I just want to get rid of the 2's. So now I got x plus y dy dx, 0. Now what do we do? Right. Now what do we do? Divide by y. That's the slope. Okay, that's the derivative. You see how it's dy dx? You just found the derivative. But that's fine. But now we have to do it at 3 comma negative 4. So dy dx at 3 comma negative 4 is what? Negative 3 over negative 4, right? Don't forget the negatives. Okay, what shape was that?
A circle.
A circle, because it's x squared and y squared. So we have, it's negative x over y. So there is a negative from that. X is 3 over negative 4. Right?
The negative doesn't apply to the y too.
No, you only do it once. Okay. So here, show that, right? Calculus is a lot of show that. I've always said, it's not about the final answer, it's about the process. So most of the time you'll be given the final answer, right? So show that the slope is defined at every point on the graph, blah, blah, blah. So show that the slope is defined. Okay, I don't know what that means, but it looks like I need to find slope. I know what it means. But, right, when you're first reading it, you don't know what it means. But what do you know? You know that you have to somehow find slope. So let's just compartmentalize and find slope. Okay, so here we go. 2y, I'm just going to rewrite the equation here. Okay, right here. Just rewrote it. So look, here there is a little bit of like a preference thing. If you feel like the whole dy dx thing, like you're going to forget, go ahead and like put dy dx on both sides of these to remind you. But it's extra writing and I don't want to make you guys do it. So let's just remember that it's dy dx. So what's going to be the derivative on the left-hand side? 2? Just okay. 2 dy dx. So the derivative of 2y is 2 dy dx equals, how about x squared? How about sine y? Derivative of sine? Okay. Okay, let's go slow. What's sine of y? What's derivative of sine of y? Cosine y?
Times something.
Dy dx. Guess what? Okay, let me say something. Let me say something. Here's where this comes from. This is actually, look, this is actually chain rule. Because remember when you were doing like the derivative of sine is cosine? Yeah. Y. Now you have to take the derivative of the inside. What's the derivative of the inside? Dy dx. So it's just a chain rule.
That's the derivative of y dy dx.
Right.
Yeah, is it?
Yeah.
Oh.
That's what that is. That's just the chain rule. Yes, okay, go.
Why do you keep the y on cosine but not on 2?
Okay, so here's why. Suppose, let's go back to last week, okay? So look, what's the derivative of 2x?
2.
Okay. What's the derivative of sine of x?
Oh, cosine of x.
Right, okay. We have to solve, okay, we have to solve for dy dx. So here we have an issue because dy dx shows up in 2 terms. You have to bring everything with a dy dx to the same side, then factor things out. So first let's do that. 2 dy dx minus cosine y dy dx equals 2x I'm gonna factor out a dy dx. Lots of times, okay, that's what you're gonna have to factor out. Okay, what do I have from the first term left over?
2.
Minus equals 2x. Now, going over here. What do I have to do now?
Now you're gonna divide by.
Divide by the parenthesis, right? Divide by the parenthesis. So dy dx is 2x.
over 2 minus cosine y. That's all.
Can I ask like a technical?
Yeah,
When you're like dividing that, just imagine you're like writing it out down there.
yeah,
Are you dividing it just the? Okay, so you're doing the whole
yeah.
side of it. Okay.
I feel like we can't.
Okay, but we're not done yet.
Divide by 2 on the top and the bottom.
Because we haven't done it, well, we're done with that, but we haven't answered the question. The question was, show that the slope, we've now found it, is defined at every point on the graph. Well, so let's see, is there a point where this will be undefined? Is it possible to plug in an x or a y for this to be undefined? So, okay, so if you plug in 0, what's cosine of 0?
1.
So that's cool, we can have that.
We can't have sine.
But
Well,
0 can't be divided by
But y can be any value.
So x
2.
can't be 0.
Huh?
X can't be 0.
X can be 0, because 0 over anything is 0.
Oh, it's 0.
Cosine of y cannot be 2.
Okay, can cosine of y ever be 2? No, so that's it, we're done. Because the highest it goes is 1, the highest it goes is negative 1.
What makes it 2?
Huh? Nothing, cosine can never be 2.
The highest it goes is 1.
The highest it goes is 1,
And
the
0.
lowest it goes is negative 1.
So
1, 0, negative 1,
Oh.
1,
Wait,
0.
isn't it this way? Is it cosine this way?
Oscillation.
When you graph though, the cosine,
is the x.
it goes highest to 1. Okay, so to write this, okay, so you could just say like no value of x or y will make dy dx, you know what, I don't like writing it slanted like that, undefined. Okay, 2 for what? Well, it doesn't, well, so if y is 2, cosine of 2 is still somewhere but like over here, right? The idea is you can't have cosine of y equal 2, but cosine of y is never 2. It's only between 1 and negative 1.
So anytime it's asking this kind of question, there's like a cosine or sine or anything, whatever, there's never going to be a value that can make it defined at every point.
It's too general. So cosine is defined everywhere. Cosine itself never has any gaps. The domain is all reals. The issue here is the denominator ever 0? For the denominator to be 0, this cosine has to be equal to 2. But there is no way cosine will ever be equal to 2. Because no matter what you put inside the cosine, itself is never like
Cosine
past
y.
1 or negative 1. Cosine y, yeah. Cosine x or y.
So if it was just like 2x over 2y, then you would say
Yes,
0
then yes.
is a value that
Correct,
can make
yeah.
What
define
is
every point.
cosine x?
Like if there was another problem, like
No, I know, right. Like,
Yeah.
if cosine x was the denominator,
uh-huh.
what? Because wouldn't that be different then?
No, it would still be the same because there's no way to put anything inside the cosine and make the whole thing equal to 2.
Oh.
Right.
Okay, yeah.
Okay.
I'm sure the denominator won't ever be equal to 2, so it's not like something you need to know.
Yep. Okay. Okay. Maybe I'll stop here because I'm taking 2 days for this. But let me tell you about homework. So the homework I want you to do is so number 11. They're gonna be random ones. 11, 29, 31, 35, 52.
Do those or don't?
Do those.
Okay.